Okay, ich begrüße Sie zum 5. Interview anlässlich der Componeers VIP-Bühne, anlässlich der Session Embedded Technology. And we will switch to English now. And I welcome Mr. Sandeep Modhvadia. He is Chief Product Officer at Wind River. And we will talk about manufacturing excellence through IT/OT convergence and enablement of Edge AI. From a systems architecture standpoint, how do you define IT/OT convergence, and what technical characteristics distinguish a converged environment from traditional coexistence models?
Sure, great question. I think a lot of it depends on which angle you're coming from. So should IT be more like OT? Should OT be more like IT? Does convergence mean they become the same thing, or is it neither? And I think both domains can learn from one another. And I think typically the patterns that you see are really the strengths of each side. OT has strengths around determinism, around longevity, around reliability. IT has strengths around flexibility, the open nature, and whether it's protocols or sourcing, and then the disaggregation of hardware, software, and application. And so when we think about the convergence of those two, it's really about determining what is the goal you're trying to drive, and then how do you cherry pick the right capabilities to help you towards that goal. But I don't believe that there is a whole-scale natural convergence of both industries where they both become one.
Legacy industrial systems were never designed for cloud-native integration. And what architectural or interoperability challenges do you see most often when modernizing brownfield OT environments?
Yeah, it's a great question. There's really, I would say, two general trends that we see. The first is compute is becoming more powerful and more cost-efficient at the OT layer. And as a result, we have all this spare compute capacity that's not being used in the equipment. And so there's an expectation that equipment should be able to do more. And so we start putting more workloads on the equipment. So I think the silicon growth, the silicon evolution drives one of those. The other is then connectivity. That device has data, and that data inherently has value. And if I can extract that data, then there must be some value in there. And typically we see one of those two as being the prime drivers. Either the data has value, therefore let's get it out, and that leads us to use cases like, say, predictive maintenance, or the compute provides the opportunity to push more applications or more software down to that device, so we expect it to be able to do more. And so when you think about, what are the architectural patterns that govern those two things, cloud native tends to help on the latter, because now what we want is that device to be far more agile, to be able to push software down to it in a more iterative way, kind of similar to how we think about CI/CD. But as we know, practically in real terms, the notion of fast software updates, move fast, break things, doesn't work in an OT world very well.
Mm-hmm. And how do you see the relation of cloud and edge in OT environments?
I see them as complementary. I think the first thing you have to determine is, what is the role of the cloud? Right? Without a use case governing where the benefit's going to come from, you can connect anything you want to the cloud. You can get all that data, but all that ends up happening is, best case, you get the illusion of insight. Worst case, you get none of the insight, and you're paying all the cost of the storage and the ingress and egress. So you have to be really very specific about what outcome are you trying to drive for. And it typically comes down to one of three things. I either want greater productivity and revenue, I want improved costs, i.e. take my costs down, or I want to manage my risk and reduce my risk. And so if you anchor it around one of those three areas, you typically find a business benefit, and then you can determine if we should attach the cloud to the edge, and if that's going to help us get towards that outcome.
Mm-hmm. Edge AI introduces new real-time and deterministic requirements. How do manufacturers deploy AI inference at the edge without compromising latency guarantees, workload isolation, or system reliability?
I think that last one, the system reliability, is the hard one, right? So I think deterministic behavior or a deterministic system and intelligence systems are in constructive conflict with each other. You can have degrees of one, but you can't have the absolutes of both. So you have to decide how much latitude you want to give your IT model that lives in your OT world. So, for example, let's take an autonomous factory, and let's say you have a robotic arm that sprays vehicles, it does paint shop for the vehicles. I would love if that arm could intelligently detect there was a defect and repair it in the moment. Right? You talk about that near-term latency. What I don't want is that arm to move out of bounds and start spraying another vehicle while it's targeting one, because now I've got two problems instead of one. And so the way that you solve that is you create hard boundaries around that intelligence, and you can say, look, you can operate within this box. You can't go outside this box. So there's a deterministic box that bounds the intelligent behavior. And so as an administrator, you have to be comfortable with the fact that your model at the edge can never have true independence. It can never have true autonomy. What it has is the illusion of autonomy within deterministic bounds, because that deterministic bounds is what keeps your business safe.
Okay, and what role do hybrid and distributed cloud architectures play in coordinating edge workloads? And how do you manage synchronization, resilience, and failure domains across these environments?
Great question. So the question, the root of that is, if you take the first part of the question, where should that data live? Where should your cloud live? What type of cloud do you need? And a lot of that will just, there's a technology decision, there is a cost decision, and there's likely to be a regulatory decision associated with that, right? So if you think about capability, cost, and then the legal side, the legal side is the one to consider first. Are you allowed to exfiltrate that data to a public cloud? And the answer to that is no. Then that kind of answers your first question. That says you probably need a near cloud close to the factory. If you need something that has fast latency and you don't want to pay all of the ingress and egress and storage costs, you might need a cloud that's local to you. But if latency isn't an issue, if you're cost conscious and you don't have the legal requirements, then public cloud might be the right option. So I don't think there's any one right answer. It's a multi-dimensional problem, and you have to do the risk assessment according to what your outcome is. And then the second part of your question was really around, okay, well, what does that design and full end-to-end infrastructure look like? And I think at that point, what we're learning is that the cloud and the edge are not two separate components that just happen to talk to each other. Like, you have to design them together, right? Okay. And when you try and build separate devices and then you plug them together, it doesn't quite work. And we've all experienced this at home, right? Like, when you buy things from two different vendors, a Bluetooth headset from one vendor and a phone from the other, it's not quite as elegant as when you buy them together and they've been designed to work together. So I think that's part of the learning that we have to do is OT administrators and IT administrators need to come together, align on the higher level business goal, and then they can design together rather than each looking for best of breed and then figuring out how to drive interoperability.
Mm-hmm. That means cloud and edge build something like a team.
Absolutely. They have to be a team, right? And I think the core of that is we sometimes think about silos and departments, or we think about business functions or subsidiaries. But the business goals are the same, right? The business goal is, make a customer happy, meet the end of period financials. And, that is the responsibility of both IT and OT. They have the same goal. Satisfy your customer, satisfy your shareholder. And so if they work across those common goals, then yes, we become one team. But if their goals are, I need my systems to have uptime and I need my production line to have uptime, their goals are different and their behaviors will be different as well.
Mm-hmm. Data sovereignty and regulatory control are increasingly influencing cloud strategies. How do these constraints shape infrastructure design for industrial AI and edge computing?
Yeah, I think the first thing there is engineers and OT practitioners are not legal experts, right? They are not law experts, they're not regulation experts, they're not compliance experts, they're not governmental experts. You have teams that do that. And so allow the policy that is mandated to flow down and treat that as a hard requirement for those teams. And then secondarily, understand that those requirements are likely to evolve. They may evolve slowly, they may evolve quickly. And on top of that, if you operate in multiple geographies with multiple regions, you may have regulation that falls in conflict with each other. And then you have to figure, okay, how do I satisfy both? Once you've determined all of those things, Then you can take that down to a set of requirements to your IT department or your OT department and say, look, you have to straddle these lines and operate in this area. Like, this is your deterministic box, right? You have latitude inside, but you can't cross these boundaries. The hard part is, as regulation changes, can your teams keep up? You know, you take something like CRA. We've had many years to understand how to deal with CRA. And so organizations are moving in that way, and you might have a 2 or 3 year lead time. You're like, great, I've done it. Once you've done it, it may already be out of date because the world changes, the policy evolves, the needs evolve. So then the question is, do you have enough agility? And is that a muscle that your organization has built so you can update your data strategy when the law changes? That you can update your data strategy when there's a geopolitical shift. And I think that's actually the hard part. It's not getting compliant, but it's staying compliant whilst remaining agile.
How does a unified infrastructure platform support both general purpose IT workloads and mission critical OT workloads with hard real-time characteristics?
Oh, hard real-time characteristics and determinism are, I would say, alien to the world of IT. Right? So if you think about how we build systems, in the world of OT, we build for reliability. Right? So we build something that has absolute uptime and never needs to be turned off. In the world of IT, we build for redundancy. We expect it to fail, and so we build enough redundancy in the system so it gives you the illusion of absolute uptime. So the industries have evolved in very different ways to get to the same outcome. So the question there is, should one industry change everything they've done to look like the other? And I think that, we're too far past that, right? It's like changing human DNA. Trying to get adults to behave completely differently. Instead, what we need to do is find the common bounds. Where are they doing things that are similar enough that by bringing them together, you get economies of scale and you can find cost savings and you can get efficiencies? Data lakes are a great example. There's a huge amount of data being built coming out of the OT world. In the IT world, there's a huge amount of data coming out. So why would we need 2 separate data lakes or 2 approaches to a data lake? Because the entire premise of a data lake is you can shove everything in one place, right? So if we find those common threads, if we find the intersection of the Venn diagram, that's where we should focus rather than trying to move the outer bounds towards the middle and trying to get the things that are really different to be common.
Automation and orchestration are often cited as key enablers at scale. What specific lifecycle management challenges do they solve in highly distributed industrial environments?
Yeah, the challenge with a lot of these highly distributed environments is even though the functionality is distributed, the management is centralized, right? The ownership is centralized. And so we know the stories of, I'm a regional manager and I've got 500 sites to manage. And I need, I want to have one single NOC to manage all of them. And so the challenge there just becomes actually similar to IT branch offices. So you think about the IT world, they manage branch offices for decades. Think about retail banking, you think about restaurants, you think about standard retail, you think about just general office space. We've learned in the IT world how to manage large distributed sites as one from a central location with minimal IT support on site. So again, I think there's learnings we can take from the IT world about how do we deal with connectivity, how do we deal with data harmonization, how do we deal with standardization of data, how do we do single pane of glass management across a heterogeneous environment. Like, there's learnings there that we can take that will be valuable. But to my earlier point, pick what works and smooth that in and slipstream that in. But you trying to change the fundamental DNA of OT is going to be very, very difficult. So complement it rather than trying to replace it or update it.
As AI models evolve and workloads grow, how should manufacturers approach long-term scalability, versioning, and lifecycle management of edge applications?
Yeah, I think carefully is the word. I think that's the word we have to do that, right? Again, remember, the flexibility and power of AI is in direct conflict with the stability of and determinism and real-time nature of OT. So what we really want to do there is understand, okay, what are the steps that we can take to get there? You cannot do this all in one go. Things will break. So think about the maturity model and where you want to get to. You start disconnected, then you move to connected, then you move to insightful, then you move to predictive, then you move to intelligent, then you move to autonomous. And you have to think about what level in that maturity model do you want to get to? And once you determine that and the business value behind that, then you can move there. So in the case of something like AI models and the like, you have to first think about, okay, I don't need AI at the edge. Let me run it in the cloud and test it, validate it, and then I can take the lessons manually and apply them downstream. When most companies are not at the level where I can say, look, I'm going to automate the learning and inference and the testing and updating of the model and push it back down. Even the best, most world-class organizations with near unlimited resources still don't do it that way. They still have human in the loop. And so I think it's important to not overestimate the capabilities, even though they seem simple, and to put the checks and balances along the way that allow you to protect and safeguard, and most importantly, earn the organization's trust. Because that's the hard part, because if the people don't trust the system, if there's too many failures, the body will reject the organ, right? And then the entire thing fails. So incremental benefits that people understand will allow for more benefits later on, because you're going at a measured pace that has success all the way, as opposed to having to wait a huge time, and success is not guaranteed.
Okay, Sandeep, thank you very much for the interview.
My absolute pleasure. Thank you.
Thank you very much.